myself, Professor Thomas, and Professor in Department of Agar. We will discuss thermal metamorphism of calcareous rocks. The content includes introduction, type of and SIO diagram for or dolomite, phosphite in contact as well in metamorphism. On the basis of temperature, we can divide metamorphism into three types, mainly low pressure, phases of and phases of high pressure. Mayasiro originally recognized three different phases series. First, a zeolite, prehenite, pumpelite, blue schist, eclogite type. Second, a typical Barrovian type characterized by green schist, epidote, amphibolite phases, gammalite phases type characterized by paragenesis of kyanite, selemonite type. And third, an Abukama type of green schist, amphibolite, gammalite characterized by paragenesis of andesite, selemonite type. Fay et al. In 1958 divide the metamorphic phases into two types on the basis of pressure, that is contact metamorphism where pressure is less than 4 kilobar, and regional metamorphism where pressure is more than 4 kilobar. Turner in 1968 and 1981 has described the classic account of contact metamorphism where temperature induced recrystallization is important. The contact metamorphism is best observed in calcareous rocks which has been intruded by magmatic bodies like felsic or basic magma. The best Indian example of the thermal metamorphism is the wollastonite mines, Sirohi district, Rajasthan. In order of increasing temperature, the low pressure or contact metamorphic phases or Abukama type of metamorphisms are listed. See also Turner 1968. Albite epidote Hornfels phases, hornblende Hornfels phases, pyroxene Hornfels phases and cenidenite phases. If you will move from albite epidote Hornfels phases to cenidenite phases, usually temperature increase. The mineralogy of impure calcareous rocks or limestone or silica bearing limestone in a contact metamorphic areoles was first described by Warman in 1940, who recognized more than 13 decarbonation reaction to turn several minerals in order from low to high temperature, and these are listed decarbonation series. They are tremolite Ca2 Mg5 Si8O22 OH twice, diapsite Ca Mg Si2O6, phosphorite Mg2 SiO4, periclase MgO, wollastonite Ca2 Si2O6, monticelite Ca Mg SiO4, acromite Ca2 Mg Si2O7, spurite Ca4 Si2O8 CaCO3, marvinite Ca3 Mg SiO4 twice, larnite Ca2 SiO4. To understand the thermal metamorphism of calcareous or impure limestone, we have to summarize only the calcareous assemblages right from albite epidote hornfels facies to cyanidinite facies. Although certain assemblages are common in regional metamorphism also. Important reactions during thermal metamorphism. Dolomite plus quartz plus water give rise to talc plus calcite plus CO2. Talc plus calcite plus quartz give rise to tremolite plus dolomite. Tremolite plus calcite plus quartz give rise to diopside plus water. Tremolite plus dolomite give rise to phosphorite plus calcite. Rarely observed minerals, periclase and wollastonite in regional metamorphisms are common in contact metamorphism. The important reaction for the formation of these minerals are as follows. Dolomite give rise to periclase plus calcite. Next reaction is calcite plus quartz give rise to wollastonite plus CO2. For detailed study of thermal metamorphism of calcareous rocks, we have to summarize the albite epidote hornfels facies to cyanidinite facies. In figure 1 ACF diagram of albite epidote hornfels facies, the possible additional phases are quartz, epidote and albite. Epidote, calcite, tremolite, quartz is one important assemblage. Another important assemblage is your calcite plus tremolite and plus minus quartz. Figure 2, that is your albite epidote hornfels facies, calcareous assemblage, calcite, tremolite plus minus quartz, calcite, dolomite, tremolite. Now see the hornblende hornfels facies. Important reaction, the beginning of hornblende hornfels facies is marked by the first appearance of the following minerals: diopside, phosphorite, gracilorite, andradite. Coming to night, the reaction involved in the formation of these minerals are as follows. Tremolite plus calcite plus quartz give rise to diopside plus CO2 plus water. Another important reaction is epidote plus calcite plus quartz give rise to gracilorite plus andradite plus water. Another reaction is talc change into Mg anthophyllite plus quartz plus water. Tremolite plus calcite give rise to diopside plus phosphorite plus CO2 plus water. Another reaction is tremolite plus dolomite give rise to phosphorite plus calcite plus CO2 plus water. If we will see the ACF diagram of hornblende hornfels facies, we can observe the following calcareous assemblages. The important calcareous assemblage is your diopside, gracilorite, plagioclase, quartz. Next is your diopside, gracilorite plus calcite plus quartz. Another is calcite, dolomite plus quartz, calcite, diopside plus phosphorite, calcite, dolomite, phosphorite and calcite, diopside, quartz. If you will see the CO, MgO and SiO2 diagrams of hornblende hornfels facies, we can observe the another important assemblages, pyroxene hornfels facies. The beginning of pyroxene hornfels facies is marked by the first appearance of the following minerals: wollastonite, anisotite, periclase and disappearance of amphiboles. The reaction involved in the formation of these minerals are as follows. Calcite plus quartz give rise to wollastonite plus CO2. Another important reaction is Mg anthophyllite give rise to anisotite plus quartz plus water. Mg anthophyllite plus phosphorite give rise to anisotite plus water. Magnesite give rise to periclase plus CO2. Dolomite give rise to periclase plus calcite plus water. Talc give rise to diopside plus anisotite plus quartz plus water. If you will see ACF diagram of pyroxene hornfels facies, we can observe the following assemblages and see the CO, MgO and SiO2 diagrams of pyroxene-Hornfels facies. The calcareous assemblages are as follows: diapside plus plagioclase plus gracilorite, diapside gracilorite quartz, wollastonite diapside gracilorite, calcite phosphorite periclase, spinel, calcite phosphorite spinel, calcite phosphorite diapside, wollastonite diapside calcite. Cyanidinite facies. This facies was accreted by Ascola in 1939 to cover mineral assemblages whose mineralogical composition and geological occurrences so that they have formed at maximum temperature and minimum pressure of metamorphism. Rocks of this facies are restricted to xenolith in the basic lavas and dikes and locally in rocks in the immediate vicinity of near surface intrusion. Cyanidinite facies show interesting and unusual features of mineral assemblages in calcareous assemblages or calcilcates, and high temperature minerals are present such as monticelite, millilite, spurite, runkinite, marvinite, larnite in order of increasing temperature, along with phosphorite, wollastonite, etc. The important reaction involved in the formation of these minerals are as follows: quartz give rise to tridymite at higher temperature 870 degrees centigrade and at 1 atmospheric pressure. Diapside plus phosphorite plus calcite give rise to monticelite plus CO2. Orthoclase give rise to cyanidinite. Quartz give rise to tridymite and give rise to cristobalite at higher temperature. Gracilorite plus quartz give rise to anorthosite plus wollastonite. Phosphorite plus calcite give rise to monticelite plus periclase plus CO2. Wollastonite plus calcite give rise to spurites plus CO2. Calcite plus millilite give rise to marvinite plus CO2. Spurites plus wollastonite give rise to runkinite plus CO2. Another important reaction is spurite plus wollastonite give rise to larnite plus CO2. Mineral assemblages. If you will see, on the basis of ACF and Al2O3 MgO SiO2 diagrams, the important calcareous assemblages are given below. Calcareous assemblages based on CO, MgO and SiO2 diagrams: anorthite plus wollastonite plus diapside, wollastonite plus diapside plus tridymite, diapside plus wollastonite plus millilite, diapside, monticelite, millilite, all temperature ranging from 550 to nearly 700 degrees centigrade. If you will see the higher temperature side, wollastonite, millilite plus calcite, monticelite plus millilite plus calcite. Another important reaction assemblages are phosphorite plus monticelite plus calcite, phosphorite plus monticelite plus calcite at lower temperature only, wollastonite plus runkinite plus millilite, runkinite, millilite and larnite, millilite, larnite, marvinite, millilite, marvinite and monticelite. Another important assemblage is larnite, marvinite, spurite, marvinite, spurite, calcite, marvinite, monticelite and monticelite, periclase, calcite. If you will see right from albite epidote Hornfels facies, the epidote is disappear and also formation of granular garnet, while tremolite and calcite react and form diapside at higher especially in hornblende hornfels phases. And if you will observe during pyroxene hornfels phases, we can see how the breakdown of Mg enthophyllite and give rise to anestetite, and also the all amphiboles are absent during this phases, and usually at higher temperature site the wollastonite appear, and wollastonite is formed by the reaction calcite plus SiO2 give rise to CaSiO3, that is wollastonite. And during sanidenite phases, all high temperature minerals are present, especially the calcareous minerals like wollastonite, spurite, marvinite, larnite, millilite, etc. And if you will see the economic significance of thermal metamorphism, the very important wollastonite deposit from Rajasthan, Sirohi district, that is how the calcareous rocks is metamorphosed by the intrusion of granitic rocks and formation of wollastonite. The course content on the thermal metamorphism of calcareous rocks begin with the introduction followed by the type of protolith, characteristic minerals, metamorphism of calcareous rocks, comparison from albite epidote hornfels phases to sanidenite phases with the help of ACF and CO, MgO and SiO2 diagrams. Important reaction, and on the basis of detailed study of different phases along with support of experimental data, we can conclude that during thermal metamorphism of calcareous rocks, important high temperature minerals are formed. During thermal metamorphism of calcareous rocks, temperature varies from 400 to 550 degrees centigrade to more than 850 degrees centigrade during albite epidote hornfels phases to sanidenite phases, while pressure is less than 500 bars during sanidenite phases. Thank you very much.